The question, group number and period number is given, and you have been asked to find out the atomic number of that element. Okay, so how to find out? Let's see. So there is a formula to calculate the atomic number if the group number and period number is given. Okay, so suppose the group number is 2 and your period number is 4. Okay, so and we know that period number is equals to your principal quantum number, right? Period number, it gives the information about the principal quantum number, means your n, right? Principal quantum number is denoted by a small n, right? So there's a formula to find the atomic number. Atomic number is equals to your atomic number of n minus 1 noble gases plus your group number. Noble gas plus your group number. Now let's see what are those noble gases. So noble gases, they are belongs to the group 18 elements, right? They are group 18 elements. So what are their noble gases? So it's helium, right? Neon, argon, krypton, xenon, and radon, right? So helium has atomic number 2, neon, it's atomic number 10, argon 18, krypton 36, xenon is 54, and radon 86. Okay, so basically we just give the number of these noble gases. First noble gas is your helium, second noble gas is your neon, third argon, fourth one is your krypton, fifth xenon, and sixth one is your radon. Just remember the position or the number of this noble gas. Okay, accordingly you can just find out the atomic number. Okay, just remember this: helium, neon, argon, krypton, xenon, and radon. Okay, so just you have to just remember the sequence. Okay, so first let's see these group number is given to, and the principal quantum number, or you can say period number is 4. Period number is 4 means your n is equals to 4, right? Period number, it just tells us about the principal quantum number, means your n, right? So n is your 4. So what will be the atomic number? So it's atomic number of n minus 1. Atomic number of n minus 1 means your 4 minus 1 noble gas. 4 minus 1 noble gas means your 3, third noble gas. 4 minus 1, right, means your third noble gas plus your group number. What is the group number? So it is 2. It's 2. Now you just have to check which noble gas lies on the third position, right? So third position is captured by your argon, right? That's why I just told you, you just have to remember the sequence wise, right? Helium, first position, second position, neon, third position is argon. So the third noble gas, atomic number of third noble gas. So it's argon, right? It's argon, and we know that atomic number of argon is 18. So 18 plus 2, right? So 18 plus 2, so it will give you 20. So what is the atomic number of, if the group number is 2 and the period number is 4, so what will be the atomic number? So its atomic number is 20. That's how we just determine the atomic number when the period number and group number is given. Clear, Neha and Simra?
Yes, ma'am. Yes, ma'am.
Okay, just note down. And I will give you one more question. Done?
Yes. Yes, ma'am.
Okay. So do this question. So determine the atomic number of element present in fifth period and fifth group. Fifth period and fifth group number. Yeah.
The atomic number will be 59.
Yes. Atomic number is
59.
59.
Yes, ma'am. 41, right?
Yeah, it's 41, not 59, Simra. See what you have done. So basically, formalize atomic number of n minus 1 noble gas plus your group number. Group number, right? That's the formula for finding the atomic number, right? And what is n? So n is your 5 and group number is also 5, right? So n minus 1 means your fourth noble gas. Fourth noble gas plus your group number, right? So which was your fourth noble gas? It's your xenon. Which one is the fourth? It's your krypton, right? See, it's your krypton, fourth one. And its atomic number is 36, right? It's 36. So 36 plus 5, so it will give you 41, right? So it's a 41, not 59, Zimra. Got it?
Yes.
Okay. So basically, 41 is your niobium. Atomic number 41 is for niobium. And niobium is basically a transition metal, right? And it is known for its silvery texture, silvery white appearance होता है इसका, silvery color बहुत ही shiny सा texture होता है niobium का. Okay. So there is no need. First, if in the exam or in the test, if they just ask you the atomic number only, so there is no need to write down the name of that element. Okay, just find out the atomic number. Okay, and if you know the name, so अगर आप लिख देते हो तो it's quite very good, right? अगर आप लिख देते हो तो बहुत सही. Otherwise, no need to write. Okay, so clear till here.
Yes, ma'am.
Okay, I will tell you some trick to write down the electronic configuration using the noble gases. Means sometimes you might confuse the after noble gas in which subshell you just have to put the electron. Okay, so I will provide you some trick for that. So basically electronic configuration using noble gases. Okay, so we know that helium, neon, argon, krypton, xenon, and the sixth one is your radon. Yeah, second, 10 to 8, 18, 36, your 54, and 86. These are the atomic numbers. Now, first step, always write down identify the nearest noble gas before that element. Okay, identify the nearest noble gas before the element. It will be your first step. gas before the element. Okay, for example, मैं examples के साथ साथ समझाती हूँ. For example, if I take phosphorus, right? So we know that phosphorus atomic number is 15. So just first check which noble gas come before this element, before phosphorus. Yes, Neha, which element comes before phosphorus? Which noble gas?
Neon.
Yeah, it's neon, right? So write down the neon. Neon. So it has 10 electrons. Atomic number is 10. Now, after that, after writing this, identify the noble gas. The noble gas number means this sequence. इस sequence में जो आपको find करना है, at which position the noble gas lies. First, second, third, or fourth. Okay. So identify the noble gas number. Okay. After identification, suppose let it be x. Suppose कि वो x position है. Okay. X could be 1, 2, 3, 4, and 5 or 6. कुछ भी हो सकता है, right? So then after that, third step will be then n. Your n will be equals to x plus 1. Right? X plus 1. आप x में plus 1 add कर दोगे तो you will get m. You will get the principal quantum number. Right? And start filling after the noble gas, writing the noble gas, start filling the electron with ns. Right? You just have to start with ns. Okay? Like suppose, see, phosphorus, it has 15 electrons, means atomic number is 15. So first you just have identify the nearest noble gas before the element, right? It's neon, right? After neon, so see, after this step, identify the noble gas number. So neon, it comes at the second position, right? Second position. So x value क्या हो जाएगी? X will be equals to 2, right? If x value is 2, so n will be equals to x plus 1 means 2 plus 1. So it will give you 3. So n is your 3, right? So you will start with ns, right? Ns means your 3s. You will start filling the electron, means the next electron will goes in 3s section, right? After this noble gas, just start with 3s. Okay, there are 10 electrons in this, and in S subshell, we know that maximum electron is 2 electron. In P, we know that it's 6 electron. In D, it's 10 electron. Okay, I have just discussed in the previous chapter. F में कितने होते हैं? So it's 14 electron. Yeah. So maximum S में कितने होंगे? 2 electrons. So just 3s2. Again, now three electrons are left. 10 plus 2, it's 12. Now 3 electrons are more. After 3s, the next energy level is 3p. So it's 3p, 3. Okay, that's the final electronic configuration using normal gas. Clear?
Yes, ma'am. Yes, ma'am.
Okay. Okay. अब कोई भी confusion नहीं होना चाहिए, right? So just use this step. Okay. So just remember this step first. Nearby is noble gas configuration, right? After that, assign. Just check the noble gas number. Let it be x. Then n is equals to x plus 1, and start filling the next electron. Start filling the electron from ns, right? Okay. For example, if I give you some questions, question like germanium. Second one, manganese. Third one, your tin. Okay. So if you don't know the atomic number, I will mention it over here. Germanium 32, manganese is 25, and your tin is 50. Okay. Now just write down the electronic configuration using noble gas. Okay. Use this step. Okay. And just write down. Then
Then
let's tell me for germanium, what is the electronic configuration?
for germanium, argon 4s2, 3d10, 4p2,
4s2, 3D,
10,
yes, and 4p2.
4p2.
Yeah, very good. Now, Simra, can you please tell me what is the valency? How many valence electrons are there in this? Because I
Hmm?
notice, no, I notice you just have done it wrong, right? जब मैंने दिया था आपको P determine the period, block number and group number, so आपने वो गलत किया. You don't know how to write down the valence electron, how to calculate the valence electron. So see, basically valence electron are those electrons which are found in the outermost shell, right? So outermost shell means your highest maximum principal quantum number. Maximum principal quantum number क्या है यहाँ पे? 4, right? Maximum principal quantum number is 4, right? So in 4 there are two shells. Is this 4s and 4p, right? तो आपको ये दोनों का ही ऐड करना है. Valence electron is 2 plus 2, which is 4, not 2 only. Clear, Simra? Like in scandium. Like in scandium is 34, right? So its electronic configuration will be 18. After 18, 4 is 2, 3D, 10, and your 4p4. Okay, so likewise in this, the valence electron is not 4 only, it's 2, 4 plus 2, right? So outermost orbit में, outermost shell में, there are two subshells, 4s and 4p. ओके, शेल तो 4 है, राइट? फोर्थ शेल में आपके दो सबशेल्स हैं, लाइक 4s एंड 4p, राइट? सो 4p एंड 4s में दो जितने भी इलेक्ट्रॉन्स हैं, यू जस्ट हैव टू एड अप. So 4 plus 2, this is your valence electron. Valence electrons are 4 plus 2, means your 6, right? So what will be the group number? So group number will be, because see, this is your p block element, right? Because last electron goes in the p subshell, right? So p block element, for p block elements, what is the group number? So it's 10 plus your valence electron. So it's 6, 10 plus 6, so 16 group. Done? Clear, Simra? अब ये mistake नहीं करोगे आप?
Yes, ma'am.
Done? Clear now? Right. So just that's how you just calculate the valence electron. Okay, outermost subshell में जितने भी electrons हो, you just have to add up those. Yeah, second one. Yes, Neha, tell me the second for manganese. What is the electronic configuration?
Argon 4s2 3d5.
4s2, 3d, 5. Okay. Now here, what is the valence electron?
4, no, 2.
2,
2.
right? It's 2, not 4. Yeah. Now, Simra, just tell me for tin, electronic configuration for tin.
Group 10, 5s2, 4d10, 5p2.
Okay. 5s2, 4d10, and 5p2. Right. Very good. Now, just tell me what is the valence electron here?
4.
Yes, that's correct. 4. 2 plus 2, it will give you 4. Okay, now clear? Everything is clear? Now you know how to predict the period number, block number, group number, how to write down the electronic configuration using noble gases. Now it's quite simple. Okay, now let's see the nomenclature of elements with atomic number greater than 100. How to name that element? Okay, कैसे उसका नाम दिया गया जो जिसका atomic number 100 से ज्यादा है, right? Let's see. Nomenclature of elements with atomic number greater than 100. So basically, in this, name will be derived from the atomic number using root word. Okay, so basically हर एक digit के लिए एक root word दिया गया. Okay, we will see what are those root word. So I'm writing digit here. You know what is digits from 0 to 9. 0 to 9, they are known as digit, right? So for that digit, the root word is given. Abbreviation I'm writing over here. Okay. So if it is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So for 0, it's given nil. Nil. The root word is nil. For 1, it is un. Un. For 2, it is by. For 3, it is try. Right. For 4, it is quad. For 5, pen. For 6, hex. Right. For 7, it is sept. Right. 7 के लिए sept दिया गया था. Not heft, sept. Right. For 8, it's oct. And for 9, it is n. E-double-N. Okay, so that was the root word for these digits. Now abbreviation, it was given nil के लिए small n. For this, it is only U. For by, it's B. Only one letter, right? T. For it's Q. For pent, it is P. For hex, it is H. For sept, it is S. For oct, it's O. And for N, it is E. Okay, so that was the abbreviation of this root word. Okay, and basically the root names are rearranged in the order of the atomic number. Okay, and the name is ended with em. Okay, and the name basically is ended. Just write down the root names are arranged in the order of the atomic number and the name is ended with em. IUM. Okay. For example, let's see some names. For example, 101. Okay. If the atomic number of element is 101, which is greater than 100, right? So how to name this? So for 1, we will see for 1 each and every digit. So for 1, what is the root word? It's un, right? So it's un. For 0, it is nil. So just write nil, right? And for 1, again, it is un, right? Un, nil, then again un, and after the ended, the name is ended with em, right? So uni, and em, right? It's the name, this name, right? So again, if it is 103, so how we can write it? It's quite complicated name. So 1 for 1, what is the root word? So it's again un. For 0, it is nil, right? For 3, it is try, right? It is try. And the name ended with em, 3em, 3em. Okay, so uniltrium, uniltrium. It is for 103 atomic number. Okay, and if you write the abbreviation, so it's UMU, for U and T. Okay, similarly, you can just write for 101, 11, for 109, okay, for 119. Okay, you just write it down. 111 के लिए 109 and 119. Okay, so just use this root word, okay, accordingly. And after, at the end of the name, just add em. Okay, so you will get the name of the element. At first, this name was given, right? The atomic number which was greater than 100, so उसका ऐसे name दिया गया. But after that, the IUPAC name was given, and it was very different from this. Okay, like unilium, like 101 को उन्होंने बोला Mendelevium. Okay, Mendelevium. After that, 102 को उन्होंने name दिया Nobelium. Okay, then Laurentium, Rutherfordium, just like that. Okay. Yes, so for 111, what is the name of that element? You can simply just tell me the abbreviation.
Triple U.
Triple U, 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 U. Okay, for 109, Neha, tell me.
UNE.
For 119,
UUE.
that's how the name has been given according to the root word. Okay, see this. See the first. Yeah. See after 100. Yeah. So some name were given like this RF. Some name were given according to the discovery, a name of the scientist which has given the that element name. Now see this 113 UUT, 114 UUQ, right? UUP. These type of name were given according to the root word. जब उसकी मतलब प्रॉपर उसका नेम नहीं दिया गया तो दैट्स तब ये आयुपैक नेम यूज किया गया था. बट आफ्टर दैट सी दिस. या सी दिस. So they have given the name accordingly, according to the scientist. Okay, like 115 के लिए क्या दिया गया? So it's Moscovium MC, right? You can see over here. This is 115 element. Moscovium. Then after 115, it's 116 LV, right? So it's 116th element. So it's Livermorium, like it's TS, it's your Tennessine. Yeah, this OG, your Oganesson. Okay, so no need to write, no need to remember these elements. Okay, basically जो हमें याद रखना है, so these are basically your first group elements, your alkali metal, alkaline metals, your fluorine, chlorine, bromine, iodine, halogens, right? Your noble gases, your carbon family, your boron family, oxygen family. These metals are very, very important. Okay. And sometimes lanthanoids and actinoids when you read the Evlog elements. So these are again very important. And yeah, these your transition metals are very, very important. ओके, बिकॉज ये क्या करते हैं, ये जब ट्रांजिशन स्टेट में जाते हैं, एक्साइट करते हैं इलेक्ट्रॉन्स, तो दे फॉर्म कलर्ड कंपाउंड्स, राइट? सो दे शो वेरी interesting features. That's why they are very important, these transition metals, d block elements. Okay, so d block elements are again very important, so you have to just remember these. ये जो लास्ट में ये सब याद करने की कोई नीड नहीं है, राइट? So have you written this?
Yes, ma'am.
Okay. Okay, next let's see the concept of valence electron. Concept of valence electron. Okay. So basically, what is valence electron? So the number of electron in the valence shell. Okay, means your last shell में जो भी electron होते हैं, जो outermost shell में जो electrons होते हैं, they are known as your valence electron, right? So just write down the number of electron in the valence shell, or you can say outermost shell, or your last shell. Yeah, so it is called valence electron. Yeah. And basically, the valence electron, we just represented, valence electron is equals to the unit digit, the unit digit of group number, the unit digit of the group number. If the group number is, suppose it's 15, right? So your valence electron is the unit digit, means your 5 only. Okay, if the group number is 15, so the valence electron is the unit digit of the group number, which is 5. Okay, so if the it's 2, okay, if the group number is 2, so it's again a unit digit, so इसमें एक ही digit ही है, unit digit, so the valence electron is 2. Okay, okay, so I'm drawing a chart over here. Or suppose like question, just like a question I'm just giving, determine the valence electron for the following, for the following. Okay, first one, calcium. Second one, chlorine, phosphorus, oxygen, boron, aluminium, fluorine, pure gallium, silicon, potassium, 11 your carbon, and 12 your nitrogen. Nitrogen. Okay, so this is an element here. I'm writing element here. You will write group number here. Yeah, valence electron here and valency. Okay, valency here. Okay, so calcium, it belongs to which group number? So it's second, right? Calcium किसमें होता है? So it's second. Group number is 7. For fluorine, it's 17. For phosphorus, it's 15, 16, 13. Aluminium, again 13. For chlorine, 17. Gallium, 13. Silicon, 14. And potassium implies an iso-alkali. So it's first. Carbon, 14th group. And nitrogen is 15th group. Okay, so I have written the group number. Now, just tell me the valence electron. We know that valence electron is the unit digit of the group number, right? So what will be the valence number? Tell me one by one. For calcium,
2,
Yes. Fluorine?
7,
Yeah. Neha, for phosphorus?
5,
Oxygen?
6,
Yeah. Boron is 3. Aluminium 3, right? So you just have to see the unit digit and just write down the valence electron. Again, 1, 4, and 5. Okay, now let's talk about the valency. Okay, so valency. Now see, if the valence electron is more than 5, अगर more than 5 है, तो just subtract it from 8. Okay, for the valency, just subtract it from 8, you will get the valency. Okay, if it is more than 5, the valence electron is अगर more than 5 है, या 5 है या 5 से ज़्यादा है, so just subtract it from 8. Okay, and write down the valency. And if it is less than, as it is, the valence electron is equals to the valency. Okay, so for calcium, what is the valency? Yes, Simra?
2,
Yes. For fluorine?
1,
Yes, very good. Right? So 7 is more than 5. So 8 minus 7, it gives you 1. Yes, Neha, tell me for phosphorus.
5,
Why 5, bache? I just told you, na? If the valence electron is 5 or more than 5, just subtract it from
then
8.
3,
Yes. Because we know the octet rule, right? Octet rule ke according, so it's 3.
2,
Yes, next. Yes, 2. And this. Yes, Simra. This one for boron.
3,
Way again. And for chlorine.
1,
Very good. Now you got it. So it's 4 again, 1, right? 4 and 8 minus 5, it's 3. Okay, so that's the valency, valence electron, group number, and your element. Okay, now you know how to assign the valence electron and valency. Clear? Okay, and valency is what? So valency basically it tells about the combining capacity of any atom. Okay, how many atoms it can combine. So valency is what? So uh if you want to write down, so you can. So it tells about combining capacity. Combining capacity of an electron of an atom. Okay, just write it down. Written?
Yes, I'm done.
Okay, now let's check if the word valency came. So let's check how you know how to write down the formula for the following or not. Okay, so write the formula for the following. First one is your magnesium chloride. Magnesium chloride. Second, potassium iodide. Third is your aluminium oxide. Fourth is your potassium bromide. Fifth, calcium nitride. Okay, so just write down the formula according to the valency. If you know the valency, you can easily write down the formula. Okay, I'm doing for you like first or second. First one, see the magnesium chloride. So for magnesium, we know the symbol Mg, and for chloride, it is chlorine, right? So it's two, valence is two for magnesium, and for chlorine, it is one. So you will use the crisscross method, and the formula is MgCl2, right? For another example, let's talk about your aluminium oxide. Okay, aluminium oxide. So aluminium, right? For oxide, oxygen. So aluminium की valency क्या होती है? So it's 3, right? And for oxygen, it's 2. So let's crisscross this. You will get Al2O. Okay, so that's how we just write down the formula. Okay, do the rest of the question. Salt. Completed.
Yes, Amra.
Okay, just for potassium iodide, just tell me the answer, Simran.
Ki.
Okay. Yes, Neha, just tell me for potassium bromide.
KBr.
Yes, it's KBr. Yes, Simran, calcium nitride.
Ca3NO3 2.
NO3 too?
Yes, ma'am.
No, it's nitride, not nitrate. For nitrate, we have NO3 minus, right? For this is for nitrate, right? और ये होता है nitrite के लिए for nitrite. If it is nitrite, then it's NO2 minus, right? And if it is nitride only means N3 minus, right? Means the valence is 3 and which is denoted by only N. Okay, so if आप N से denote कर, the symbol will be N, not NO2 or NO3. Okay, so for calcium nitride, it's calcium, and for nitride, N. Calcium, valence is 2. For nitride, it's 3. Now just crisscross, you will get Ca3 and okay.
Okay.
Similarly, do it for aluminum nitride.
ALN.
L and yes, good. Al and okay, so for aluminium, it's 3. And again for nitride, it's 3. Valence is 3. So this 3 will cancel out. Right? Al3 and 3. This will cancel out and you will get Al. Yes, Neha, just last one. Just tell me the formula for the last one, magnesium oxide.
MgO.
Very good. G- Okay. So the next one, so we will discuss all the block elements like S block elements, P block, D and F block in details. Okay, so just starting with the S block elements. S block elements. Yeah. So basically, S block element. We know what is the location of S block elements. S block in the periodic table. S block elements lie on the extreme left. Okay, extreme left of the periodic table. And basically S block elements includes metals. Okay, metals hote hain. Basically S block elements, they have two groups. One group which is alkali metals, second group which is your alkaline earth metals. Okay, so basically they are metals. Write it down. So S block elements lie on the extreme left of the periodic table, and it includes metals. and it is composed of two groups, because we know that S, just remember S subshell has maximum 2 electrons, right? 2 electrons हो सकते हैं, that's why they are composed of two groups. Okay, so S block elements, it is composed of two groups, as each S subshell can have maximum of 2 electrons. Maximum of 2 electrons. Okay. So basically there are two groups. A group is group number one. Group number one. And what are these group names? So they are called as alkali metals. Alkali metals. Right. So they are metals, so they have the tendency to lose electrons. Okay, so they are metals. You can write. They have tendency to lose electrons. They are alkali, right? So they are alkali means whenever you just put this in the water, so they increase the concentration of OH minus ion, right? अगर आप alkali metals को water में डालते हो, right? Water के साथ react कराते हो, so they just increase the concentration of OH minus ion in water. Okay, so you can write they increase concentration of OH minus ion in water. Okay, so that's for group first elements. Now let's see what are those groups, what are those elements which are found in this group number. So I'm just writing here. So it's hydrogen, lithium, sodium, potassium, rubidium, cesium, and tritium. Yeah. So atomic number 1, lithium. Atomic number 2, sodium 11. It's 19, 37. For cesium 55, and for this 87. Okay, so if you assign a period number, so hydrogen it belongs to first period, lithium it belongs to second period, third, fourth, 5, 6, and 7. Okay, so this is a period number. So hydrogen belongs to first period, lithium second period, sodium third period. Okay, and if you write down the electronic configuration of these, right? So it's 1s1, right? It's 1s2, 2s1, right? It's, I'm writing the noble gas electronic configuration. So neon 3s1, argon 4s1, and accordingly you can just write, right? Accordingly you can just write on the electronic configuration of all these. Yeah. So simply you can just see there is only one electron, right? Means the valence electron, you can see one, right? So they just belongs to first period. So basically, when we talk about the general electronic configuration of your group number first, your alkali metals, so your general electronic configuration will be NS1, right? NS1, right? So you can see this is NS1, right? 2s1, 3s1, and N could be your 1, 2, 3, 4, 5, 6, 7. Okay. And what is N over here? So N is your period number. Period number. And for the group number first, you can see the valence electron. The second valence electron is 1. Yeah. So each and every, you can see the valence electron is 1. Right? Is 1. And what is the valency? Valency is again 1. Yeah, so these are for alkali metals. Means you group first elements. So group 1 elements. Okay. So general electronic configuration, just remember NS1, and N is what? N is your principal quantum number, you can say, or your period number. Or valence electron is 1, okay, and valence is again 1. Yeah?
Yes, ma'am.
Yes, ma'am.
Yeah. And if you want the mnemonics to just remember this group number, so here's the mnemonics, I'm writing it over here. Henry Lewis nearly knocked racing cars furiously. Racing car furiously. Right. So आप इस mnemonic से भी you can just remember. Henry Lewis nearly knocked racing car furiously. Okay, so this is your for Henry. It is hydrogen, lithium, sodium, potassium, rubidium, cesium, and strontium. Okay, just write it down. Then we will see the group number 2. Right, group second, which is your alkaline earth metals. Written?
Yes, ma'am.
Okay, let's see the second group, which is group number 2. Right, and this group is known as your alkaline earth metals. Earth metals. Now, here's a question: why they are known as alkaline earth metals? Okay, so basically, they are oxides. When you make the oxides and hydroxide of this, so they are alkaline. They are basic in nature. Okay, so basically, group second oxides and hydroxide are basic in nature, alkaline in nature. Okay, and ये जो oxides होते हैं, they are found in Earth's crust. Okay, so Earth's crust में पाए जाते हैं, they are naturally found in Earth crust. That's why they are known as alkaline earth metal. Got it?
Yes, ma'am.
ma'am.
Let's see. And basically, like your magnesium, your calcium, etc., they are found in Earth crust. Okay, so let's see what are these period. So basically, this group number 2 starts from the second period. Lithium, the magnesium, calcium, magnesium, barium, and your radium. Second period, third, fourth, fifth, sixth, and seventh. It's 12. Calcium is 20, 38, 56 radian, it is 88. Okay, so if you write down the electronic configuration, so it's 1s2, 2s2. Okay, it's neon 10 plus 3s2. It's argon 4s2. Similarly, array unaccepted. Okay, so along with accordingly, just write down these two. Now let's talk about the general electronic configuration. So general electronic configuration for the alkaline earth metal group number 2 is general electronic configuration is NS2, right? Sorry, this is NS, not NS1, it's NS2. Yeah. So for group number 2, it's NS2. For group number 1, it is NS1. Okay. So N, again, N is your period number. Okay, now just tell me what is the valence electron over here, valence electron and valency. Valency and valence electron in this.
2.
Yes, very good. It's 2. Okay, so just remember this. And here's again a mnemonics for this. So you can write big mice, big mice can scare brown rats. Brown rats. Big mice can scare brown rats. Right. So you can use the mnemonics to just remember these sequence. Beryllium, magnesium, calcium, strontium, barium, and your radium. You write it down. Done?
Yes, ma'am.
Okay. Next is your P block element. So basically, P block elements, they are composed of 6 groups. Okay, because as the P subshell can hold 6 electrons. Okay, because P subshell can hold 6 electrons, so it is composed of 6 groups. Write down. It is composed Yeah, so it's from group 13, right? Group 13 to group 18. Group 18. And yeah, just remember this block includes some metals, non-metals and metalloids. Yeah, तो P block में metals भी होते हैं, non-metals भी होते हैं, and there are some metalloids also. Yeah, and basically the P block elements lie on the extreme right of the periodic table. Okay, P block कहाँ पे होते हैं? They are extreme right on the periodic table. And basically S block, just remember S block elements plus your P block elements, they are collectively known as main group element, main group or representative elements. Okay, so just write down this block includes some metals, non-metals, and non-metals ज्यादा होते हैं, right? P block में non-metals ज्यादा होते हैं, कुछ metals होते हैं, and there are some metalloids also. And yeah, basically S block and your P block elements are collectively known as main group elements. Main group or representative elements. Okay, write down the location also. P block elements, they lie on the extreme extreme right of the periodic table. Okay. Okay, let's see the first group element. Okay, so I will not discuss all the elements, all the group, like from 13 to 18. मैं सिर्फ एक बताऊंगी, okay, and I will tell the general electronic configuration, and that's your homework to write down the electronic configuration of all the elements, all the group elements. Okay, from 14 to 18. Okay, so similarly you will write. So it's period over here. Okay, first write down. Group 13 elements. So what are group 13 elements? So basically they are boron family. Boron family. So remember the name. So it's bag it. Bag it means boron, aluminium, gallium, indium, and UTL. Right? Bag it. So I'm writing period number here. Okay, it's 2, 3, 4, 5, 6, and 7. So it's boron, aluminium, 7, only till 6. Okay, okay, write down the atomic number first. So it's 5. For aluminum, it's 13, 31. Indium, it's 49. And for tellurium, it's 31. Okay, now try to write down the electronic configuration using noble gas. It's helium, right? Helium, 2s2, 2 p 1. This one, it's neon, 10, 3s2, 3 p 1. Argon, 4s2, 3d, and For indium, it's krypton is a nearby. After krypton, it will goes in 5s, 5s2. After 5s, 4f10, 5p1. Xenon 6s2. Yeah, this is a F block. 4f is 14, 5d, 10. You just have to remember the energy order of energy, and accordingly just substitute, just fill the electrons. Okay, so these are the electronic configuration. Okay, now see again the valencies. Valency is now 3. 2 plus 1, 3. 2 plus 1, 3. 2 plus 1, 3. Okay, so just now write down what is the general electronic configuration. So it's NS2. You can see it's NS2, NP1, NP1. Okay, so basically the last electron, it goes in the P block. So that's why it is a P block element. Okay, so general configuration of the basically group 13 elements is NS2, NP1. Okay, it's not for a group 13 only. It's for the whole P block element. This general electronic configuration is for the whole group UP block elements. A general electronic configuration. Now, valence electron. Valence electron. How many valence electrons are there? So 2 plus 1. So it's 3. 3 electrons. And what is the valency? Again, it's 3. Just write up. Yeah, so homework here, homework is similarly just like that, just like the above, complete all the groups, all the groups of P block. Okay, means from P blocks means from 14 to 18. 14 to 18 तक का आपको लिखना है ये all the general electronic configuration, right? Block elements. And yeah, just remember this general electronic configuration. See this NS2 and NP1. Okay, so basically this is for group 13 elements, right? अगर general किसी का भी अगर like group 14 elements, so it will be NP2. Similarly for group 15 elements, so it's NP3. Okay, so basically general, I'm writing here. This is for general electronic configuration for 13 elements. Group 13 elements. Yeah, I'm writing the general electronic configuration for P block elements, all the P block elements, right? It's NS2, NP1 to 6. Okay, it's from NP1 to 6. Okay, 1 किस case में होगा? So it's a case of 13 group elements. So when it is group 14 elements, so it will be NP2. When it is 15 groups, so it's NP3, and similarly, it just goes on. Okay, so basically the general electronic configuration is this. Accordingly, you just have to fill the electrons or write down the electronic configuration. Got it?
Yes, ma'am.
Yeah, so that's your homework. Yeah, so complete all the groups of P block elements. So I have mentioned one group over here, right? So 13 group elements. So आपको क्या करना है? 14, 15, 16, 17 and 18. Okay. Similarly, just write down the name of the element. Okay, its atomic number, its period number, electronic configuration, and the general electronic configuration, valence and valence. Got it? Yeah. And just mnemonics for this is here you can see BAG, BAG and IT. Okay, so I already just told you what are the mnemonics. Accordingly, you just remember the elements according to the group.